This is the second part of the part 2 series of the sum and difference identities for sine and tangent. All right, so we still have to find the tangent of s plus t. So let's go ahead and use our formula. It's going to be the tangent of s, which is negative 2 radical 6, plus the tangent of t, which is negative 3/4, over 1 minus the tangent of s times the tangent of t. Okay, so let's go ahead and multiply everything out. So I get negative 2 radical 6 plus negative 3/4 all over. Hey, maybe we should just find a common denominator and add the numerator and add the denominator. Yeah, let's do that. Let's do negative 8 radical 6 minus 3 over 4 divided by, so this is going to have a denominator of 4 as well. So this is going to be 4 minus, let's see, 6 radical 6 over 4. So when we multiply by 4 over 4, our denominators are going to reduce. And we're going to be left with negative 8 radical 6 minus 3 over 4 minus 6 radical 6. We can't leave it that way because we're not allowed to have radicals in our denominator. So let's go ahead and rationalize. So I'm going to have negative 8 radical 6 minus 3, 4 minus 6 radical 6. I'm going to multiply that by 4 plus 6 radical 6. And when I do, I'm going to get a negative 32 radical 6, a negative 48 times 6, a negative 12, and a negative 18 radical 6. All over, I'm going to get 16 minus 36 times 6. So when I combine like terms, I know I have negative 18 and negative 32. That's going to be a negative 50 radical 6. And then when I multiply 6 times 48, I'm going to get 288 minus 12. And now in the denominator, I have 16 minus, that's 216. So this is going to be a negative 50 radical 6. And then this is going to be a negative 300 all over a negative 200. Well, what goes into all of these numbers? I would say a nice 50 does, a negative 50. So let's divide everything by a negative 50. If I divide by a negative 50, I'm going to get radical 6 plus 6 over 4. And that will be my final answer. And now let's find the quadrant. So s plus t has a sine of this and a tangent of this. This, if I take out a negative, 3 plus 8 radical 6 over 25 is negative. Sine is negative. Tangent here is a positive number. So what quadrant is sine negative and tangent positive? S plus t is going to be a Q3 angle. Awesome. Okay, so now we're going to do a couple of examples where we're going to find the exact value of a given trigonometric function. Okay, so how can we find the sine of negative 13 pi over 12? Well, we can find two angles that subtract or add to negative 13 pi over 12. So let's see. So this is definitely going to be a Q3 angle because this is a whole pi plus 12 over, or plus 1/12 of pi. So maybe we could do, let's see, maybe we have 2 pi over 3 plus, what would that be as an angle over 12? Well, that would be 8 pi over 12. To get to 13, I would have to add 5 pi over 12, but we don't have that. So let's try 3 pi over 4. Let's see if that one works. 3 pi over 4. If I change that to something over 12, that's 9 pi over 12. I would have to add a 4 pi over 12 to that, which we do have, okay, because that is a pi over 3. Okay, so I found two angles that would add to a positive 13 pi over 12. All I have to do is put negatives in front of them. So this is the sine of negative 3 pi over 4, and it doesn't matter which way you put them in, minus pi over 3. So I'm going to use my formula for the difference of angles for sine. So I know this is going to be the sine of negative 3 pi over 4 times the cosine of pi over 3. Okay, so since I'm using the difference formula, this is A and this is B, minus the cosine of negative 3 pi over 4 sine of pi over 3. So I know negative 3 pi over 4 is negative 135 degrees, so that's going to be in quadrant 3. So the reference angle is going to be a 45 degree reference angle. So since it's in quadrant 3, it's going to be negative because sine is negative there. Cosine of pi over 3, that's 60 degrees, so that's going to be 1/2. So the cosine of negative 3 pi over 4, again, that's negative 135 degrees. That's in quadrant 3. Cosine is going to be negative with a 45 degree reference angle. And the sine is going to be radical 3 over 2. So when I multiply this out, I'm going to get minus a negative radical 6 over 4. So that's really going to be a negative radical 2 plus a radical 6 all over 4. All right, so let's go ahead and try the next one. This one's going to be in degrees. So we just need to find two angles that add to 285 degrees. So let's see, we could use 240 degrees plus 45 degrees because they're on our unit circle. What else could we use? Let's see, we could use 225 degrees plus 60 degrees. There's a whole bunch of them we could use, I think. We could use 135 degrees plus 150 degrees. So really it's your choice what you would like to do. So I'm going to use the 240 plus 45. You can even subtract. You could do 300 and let's see, 15 degrees minus 30 degrees. So you could use the difference formula as well. So the tangent of 240 degrees plus 45 degrees. All right, so let me erase these. That will give us the tangent of 240 degrees plus the tangent of 45 degrees all over 1 minus the tangent of 240 degrees times the tangent of 45 degrees. All right, so what is the tangent of 240 degrees? Well, that's going to have a reference angle of 60 degrees. It's going to be Q3, right? Q3, so tangent's going to be positive. So let's draw a 30, 60, 90 triangle. 60 degrees. So this is rad 3 over 2, this is 1/2, and this is 1. So it's going to be rad 3 over 2 over 1/2. So this is going to be equal to just radical 3. So the tangent of 240 degrees is radical 3. The tangent of 45 degrees is 1. So then we have radical 3 times 1. So we get radical 3 plus 1 over 1 minus radical 3. So for this one, let's go ahead and rationalize this. So I'm going to multiply by 1 plus radical 3 over 1 plus radical 3. So I'm going to get radical 3 plus 3 plus 1 plus radical 3, all over 1 minus 3. So let's combine like terms. We get 2 radical 3 plus 4 over negative 2. So when I take a negative 2 out of the numerator, I get negative radical 3 minus 2 over a negative 2. My negative 2's reduce out. I always like to write my radical last, so I'm going to flip these. So that's my final answer. So now I think I'm going to go and do a verification. So it says verify that the sine of x plus y plus the sine of x minus y equals 2 sine of x cosine of y. So I'm going to go ahead and start manipulating the left-hand side, and I'm going to just go ahead and use the formula for the sum and the difference of sine. So I get the sine of x cosine of y plus the cosine of x sine of y. Now for the other one, I get the sine of x cosine of y minus the cosine of x sine of y. All right, so these two are gonna reduce out, and I am left with the sine of x cosine of y plus the sine of x cosine of y. Well, they're the same thing, so I have 2 sine of x cosine of y. And that is exactly what they wanted us to prove. So just by plugging the information into your sum and difference identities, this verification was fairly easy. So let's go ahead and verify this now. So again, I think I'm going to start with the left-hand side and just use my formulas. So I'm going to say the tangent of x minus the tangent of y over 1 plus the tangent of x tangent of y. So when I expand the next one, it's going to be the tangent of y minus the tangent of x over 1 plus the tangent of y tangent of x. And you can see in the denominator that my denominator looks really good there. Okay, so I can combine this into one fraction that has a denominator of 1 plus, that's a plus, not a t, 1 plus tangent of x, tangent of y. So I'm going to get the tangent of x minus the tangent of y minus, remember I have to distribute that negative, tangent of y plus the tangent of x. So when I combine like terms, I have 2 of these and 2 of these. So I get 2 tangent of x minus 2 tangent of y, 1 plus tangent of x tangent of y. And when I factor that 2 out, I get tangent of x minus tangent of y over 1 plus tangent of x tangent of y, which is what they wanted us to prove over here. Okay. Have fun with your homework.